Hello everyone, welcome back, grade 11. We are still enjoying our electrostatics and we are still on the Coulombs Law. And then we have given you one example in the previous video on how to determine or how to calculate the electrostatic force and also to determine whether that electrostatic force is repulsive or attractive. Let me just give you a recap from our previous lecture, previous presentation. We said if you are dealing with like charges, then the electrostatic force is repulsive. And if you are dealing with unlike charges, which means different, it means that electrostatic force is attractive. So I'm going to do only two more examples on Coulomb's law, how to use the formula before we move on to the next item, which is determining the net electrostatic force when we've got three charges. Right. So before I get into the first example, I want to remind you of our unit conversions. We have got different unit conversions that we need to equip ourselves with as grade 11 learners. Right. Sometimes they don't give us our charge in Coulomb, direct in Coulomb. They give us the charge in something else. So let's say, for example, they give us the charge in millicoulomb, right? That is millicoulomb. How do we convert millicoulomb to coulomb? That is the question. What we do is we multiply by 10 to the power minus 3, or we divide by 1,000, right? So MC stands for millicoulomb. This is millicoulomb, right? Remember, it is very imperative, it is very important for us to keep on changing and checking our units to make sure that our units are in coulombs. So if you are given millicoulomb, convert that to coulomb and you multiply by 10 to the power minus 3. If we are given in microcoulomb, we need to convert that to coulomb as well. We multiply by 10 to the power minus 6. That is microcoulomb. Right. What if we are given in nanocoulomb? Right. We need to convert that to coulomb. We multiply by 10 to the power minus 9. This is similar to what we have done in our previous class, and this is nanocoulomb. Right. This is nanocoulomb, right? And then picocoulomb to coulomb, we multiply by 10 to the power negative 12, and this is picocoulomb, right? So this is how we convert our units. As we are going to be doing our calculation, we need to keep on referring to our unit conversions to make sure that we are using the same units and we don't have much problems with our calculation. All right, friends, I'm going to take you straight to our second example on Coulomb's law, or on how to use Coulomb's law. So I'm going to write example 2, right? Uh, on our example 2, calculate the electrostatic force between two charges of plus 6 nanocoulomb and plus 1 nanocoulomb if they are separated by a distance of 2 millimeters, right? So it says calculate the electrostatic force, calculate the electrostatic force, all right, between two charges, between two charges, between two charges of plus 6 nanocoulomb and plus 2 nanocoulomb if if they are separated, if they are separated by a distance of, by a distance of 0.2 meters. Right, that is it. That is our example number 2. Now, what is the procedure here? How do we attack it? How do we approach it? We read the question 3 times, friends. This is physical science. We need to understand the terminology. We need to understand the idea behind the question. We need to read the mind of the examiner before we start answering the question. I always advise my learners for my school that don't attempt to answer a physical science question before you smile. So you need to smile. And what makes you smile is you have understood the question and you have seen where the examiner is trying to take you to. So let's read the question at least 3 times, then we get exactly what's happening. So calculate the electrostatic force between two charges of +6 and +2 nanocoulomb if they are separated by a distance of 0.2. So this is, to me, this is very straightforward because this is Coulombs law. We are calculating electrostatic force. We have two charges and the distance is given and the magnitude of the two charges is also provided. So what do I need? I need my given data, right? We need to write the given data or the given values. Remember, we have got our constant, electrostatic constant, which is 9,0 times 10 to the power 9. Then we have got charge 1, which is equals to 6 nanocoulomb. Go back to the table. How do we convert nanocoulomb? We multiply by 10 to the power minus 9. So this becomes 6 times 10 to the power minus 9. These are coulombs. Now, charge 2, this is 2 times 10 to the power minus 9. These are now coulombs. Distance, it's already in meters, so it's 0.2 meters. We are looking for electrostatic force, right? So what do we do there? We need the formula, and remember, there is always a free mark that you get when you state the formula as it is in the formula sheet. So that is the formula that we are going to use, and we make proper substitutions. Our f our f is equals to K, it's 9,0 times 10 to the power 9. And then charge 1, it's 6 times 10 to the power minus 9. And our charge 2, it's 2 times 10 to the power minus 9. And everything divided by 0.2 squared. So our F is equals to, alright, I can write the unit. It's supposed to be in newtons. So the advantage is the calculators that we are using these days. It allows us to put everything and then we write the answer straight. And then we determine whether it's attractive or it's repulsive. Perfect. So I need my calculator, Casio, then I put my fraction there. All right. And then I start inserting everything. I've got my constant 9,0 times 10 to the power 9. Is that okay? Then I close and I open again. What follows? 6 times 10 to the power negative 9. I close, then I open. I've got 2 times 10 to the power negative 9. I close, then I open. I've got 0.2. I close and it's squared, and then everything gives me 2,7 times 10 to the power minus 6 newtons. Now I need to determine whether it's attractive or it's repulsive. So I go back to the original question. I've got a positive and a positive, so like charges they repel. So therefore, this is repulsive, right? They repel each other. So these two charges, they repel each other with a force of 2,7 times 10 to the power negative 6 newtons. Right. So this is our example number 2, and everything is moving on well. Everything is so smooth. Right. Everything is moving on well, and everything is so smooth. Now let's look at our third example, which is the last example on Coulombs law. Then we'll be looking at three charges, right? And we determine the net electrostatic force. Suppose we are given the force, we are given the two charges, we are supposed to determine the distance. How do we do that? All right, so that is going to be our example number 3. So let's write here example 3. Now we are determining a distance. We are given force. So it's just a matter of making R the subject of the formula, because now we have been dealing with calculating force when we are given the charges and the distance. But now the examiner has decided now to give us the force and the charges. So we are supposed to calculate the distance. So what is the question? It says calculate the distance, calculate the calculate the distance between two charges, calculate the distance between two charges of plus 4 nanocoulomb, right? And minus 3 nanocoulomb. And let me say minus 3 nanocoulomb if the electron if the electrostatic force between them if the electrostatic force between them, right, is 0,05 newtons, 0,05 newton, right? So like I said in the previous example, learners, you need to read the question 3 times, because you need to understand the idea, or you need to read the mind of the examiner. Where is the examiner going? What is the gist? What is the theme of the question before you start rushing with your calculation? Right. So if I read it for the second time, calculate the distance between two charges of that one and that one if of plus 4 nanocoulomb, sorry, and minus 3 nanocoulomb if the electrostatic force between them is 0,05 newtons. So here I'm given the two charges and the force itself. So we are looking for distance, which is R. Right. At least the question is making sense. So in other words, we must start from make R the subject of the distance, because remember R represents distance, or a distance is represented by R. Right. So I always, prioritize my given data. I need my given data to be ready. Right, my K doesn't change, which is the electrostatic constant, which is 9,0 times 10 to the power 9. Then my charge 1 is given, it's 4 times 10 to the power, I convert nanocoulomb to coulomb, becomes 10 to the power negative 9. And then my charge number 2 is 3 times 10 to the power minus 9 coulomb as well. Right? And remember, we said we ignore the sign when we substitute. Right? Remember, I said that that's why I'm not writing on my given data, so that I won't confuse myself with substitution there. We ignore it, right? And then my force, which is given, is 0,05 newtons. So what is it that we are looking for? We are looking for R, not R squared. Good. So I write my Coulombs law, the formula, F is equals to K Q1 Q2 over R squared. And I want to emphasize that there is a free mark for writing that formula as it is. You get a free mark for that. So I make my proper substitution. F, it's 0,05, which is equals to my K is 9,0 times 10 to the power 9, close. Then my charge 1 is 4 times 10 to the power negative 9, you close. My charge 2 is 3 times 10 to the power negative 9, you close. Everything over r squared. Yeah, there is trouble there. Now I have to do my mathematics properly here. I can remove the fraction by multiplying both sides by r squared. Right. And for those who are doing, you guys, you are doing maths, all the physical science learners must do pure maths. Right? If you have not been doing pure maths, I want to encourage you to do pure maths because it is very close to physics and physics becomes easier for you. So we know that in maths, whatever you do to the right hand side, you must also do it to the left hand side. So I want to multiply both sides by r squared here so that I get rid of the fraction. You multiply both sides, this one and this one, they cancel out. So I'm going to have 0.05 r squared, which is equals to, now I simplify that whole thing that is on top, right, which is 9.0 times 10 to the power 9. I close, sorry for that, I close, right? And then I open again, 4 times 10 to the power negative 9. Allow me to close again and open. I got 3 times 10 to the power negative 9. 3 times 10 to the power negative 9. I close. Then I'm getting 1.08 times 10 to the power minus 7. You can always use your own calculator at home to check if my calculator is giving me correct answers. Then what do I do from there? I divide both sides by 0.05. 0.05. This one and this one cancel out. So in other words, r squared is equals to, right? So 1.08 times 10 to the power minus 7 divide by 0.05. I have my calculator there. I'm getting 2.16 times 10 to the power negative 6. So what do I do there? I put square root sign both sides so that I get my r, right? Therefore, r is equals to the square root of 2.16 times 10 to the power minus 6. Therefore, r, which is our distance, is equals to square root is there, 2.16 times 10 to the power negative 6. The power negative 6, right? And I am getting here 1.46, should I say 1.47 times 10 to the power minus 3. And remember, these are meters, right? You can verify that with your calculator there if we are getting the same, if we are getting the same, if we are getting the same answer. All right. 1.47 times 10 to the power minus 3, and these are meters. Then I underline my answer here. That is the distance between the two. So thank you so much, friends, once again for joining us. And this example marks the end of our Coulombs Law. So the next lesson or the next presentation that we are going to have, we are going to be looking at calculating the net electrostatic force when we have got three charges which are in a straight line. Then from there we go to three charges which are at a right angle. Then we are done with electrostatic force. We move on to electric field, and then that will mark the end of our electrostatics topics. So please do not miss the next video. Do not miss the next presentation, because I'm going to be dealing with three charges in a linear format, where we have got three charges which are in a straight line, and we determine the net electrostatic force. Thank you so much for joining us. Thank you so much for being part of EduBlush. We love you. You must take care, and we meet again in our next presentation.